Why do we need text preprocessing? Text data is unstructured and messy. And if we want to do anything interesting with it, first we need to normalize it. If you are working with, say, newswire text, it's relatively well written. But there is lots of text available that's not that well written. For example, there are reader comments, text messages, tweets, Facebook posts, which are not always well written. Also, even in well-written text, in some natural language processing tasks, you might not care about morphological differences. For example, if you are extracting all city names from a text, you might not care about differences such as Vancouver's versus Vancouver. Now, preprocessing is usually task-specific, but tokenization is something that you would see in almost all natural language processing applications. There are two steps in tokenization: sentence segmentation and word tokenization. Let's look at sentence segmentation. Consider this MDS text, which tells you about PhD countries of the core teaching team. I'll give you a few seconds to read the text. Okay, so how many sentences are there in this text? Now, if we decide that let's just split the text on period, because in English usually sentences end with a period, what will happen? So here I'm splitting the text on this sentence ending period, and we know that it's going to fail because we have many abbreviations in this text. There is doctor, US, and PhD. And that's what we observe here. When we split on period, then we get all these weird sentences here. It didn't identify this exclamation mark as a sentence boundary. Also, it considered this period as sentence ending marker and then separated D and so on. So the point is that in English, period is quite ambiguous. In languages like Chinese, it is not ambiguous, it is unambiguous, and you can split sentences on period. But in English, that's not the case because there are abbreviations like doctor, US, Inc., so on. Also, there are numbers like 0.98. Also, other sentence ending markers such as exclamation mark and question mark, they are also relatively ambiguous. Now you may think that, okay, why not write regular expressions? Now you can write regular expressions, but people have worked on this problem for a long time, and there are good off-the-shelf models available for sentence segmentation, which work okay in many different domains. So usually what people do is they just use these off-the-shelf models. That said, if your data is really messy, you might have to use these off-the-shelf models, and then you might have to carry some post-processing to get reasonable segmentation. And note that this is usually the first step in your natural language processing pipeline. Tokenization is usually done at the beginning of the pipeline. And if this is erroneous, this error is going to propagate in the next steps of the pipeline. Okay, so let's try to do sentence segmentation using NLTK. NLTK has this sent tokenize method that we can use for sentence segmentation. And here I'm doing sentence segmentation using this method. And now we see the results are much better. Now it identified these two exclamation marks as, so this exclamation mark as a sentence ending marker. Then it didn't split on these doctors and PhDs. So this looks pretty good. Okay, now the next step is word tokenization. Let's consider the first sentence from our MDS corpus. Now, how many words are there in this sentence? And is white space a sufficient condition for identifying word boundaries? Now, this is a tricky question, and it depends upon our definition of a word. For example, should British Columbia be one word or two words? And should punctuation be considered a separate word? What about the punctuation in the US if we consider punctuation as a separate word? And what do we do with words like masters? So this process of identifying word boundaries is referred to as tokenization. Linguists have worked on this problem for a while, and then there are good rules, good guidelines to identify what is a word. And again, you can write regular expressions to identify words, but similar to sentence segmentation, people have worked on this problem for a long time, and there are very good off-the-shelf models for word tokenization. And usually what people do is they just use these off-the-shelf models. Okay, so now let's try word segmentation on our MDS corpus. Now there is this method called word tokenize in NLTK, and now I'm tokenizing all sentences. So first we did sentence segmentation, and in each sentence now we are doing word tokenization. And now what we see is we have this, if we just split it on white space, here I'm showing you the result when I just split it on white space. And then we get these weird things like Columbia, the punctuation is attached to the word, and so on. And now here is this proper tokenization using word tokenize. And now Columbia and this period, they are separated. That said, I mean, at the end, it also separated this u.s and the period after s. Now this is tricky because in this particular sentence, US, so this period it's acting in two ways. So it's also part of this abbreviation of u.s. but it's also end of the sentence. So yeah, so the model made a mistake here. So these are machine learning models, and they are going to make mistakes. So don't expect perfection here. Okay, so for languages like Chinese and German, you need more sophisticated word tokenization, and this is referred to as word segmentation. For example, Chinese does not use white spaces between words, and German doesn't separate compound nouns. Here I'm showing you an example of a compound noun in German. I cannot even imagine saying this, but maybe we have some German speakers in the class who can say this long compound. Yeah, so the point is that we need more sophisticated tokenizers, and word segmentation or word tokenization becomes an important problem in these languages. Now in NLP, people usually talk about types versus tokens. Type is an element in the vocabulary, and token is an instance of that type in running text. Okay, and here is an exercise for you to identify types and tokens. There is a sentence, and then how many types are there and how many tokens are there. And so types are usually task dependent. So for example, you might decide to consider USA and US as equivalent, and you just decide to map them to one thing and store it as one type. Okay, so types are going to be task dependent. Okay, now there are also these other commonly used pre-processing steps. The first one, I'm going to talk about two of them. The first one is punctuation and stopword removal, and second one is lemmatization and stemming. Now you have done stopword removal before, and the idea is that most frequently occurring words in English are not very useful in many NLP tasks. And what are these most frequently occurring words? They are usually prepositions or determiners or punctuation marks. And So they are not very informative, there is not much content in them, and the idea is to just get rid of them before we do anything with that text data. So I have used stopwords from English stopwords from NLTK, and then I added punctuation marks to them. And so this is the list of stopwords. So we are telling our model that, okay, ignore all these words. And of course, depending upon your task, you can change this list, you can add to it, or you can get rid of some words that are here in English top list of NLTK. Okay, so now with that list, I'm applying that to our preprocessed, our tokenized corpus. Okay, and so now what we see is we got rid of all these stop words from our corpus. Okay, now the next thing that I'm going to talk about is lemmatization. Now for many NLP tasks, for example, web search, we want to ignore morphological differences between words. For example, if you're searching for a term like studying for ML quiz, then you might want to include pages that contain tips to study for an ML quiz, or here is how I studied for my ML quiz. So now that there are these differences, there is this studying versus study versus studied. And we want all these inflected forms to map to each other. So what lemmatization does is it converts these inflected forms into the base form. Okay, so studying, study, and studied, everything will be converted to study, for example. And here I'm showing you an example of using WordNet lemmatizer, again from NLTK, to do lemmatization. And how do we do it? We create this lemmatizer object, and then we call lemmatize method of this lemmatizer object. And then we pass the word we want to lemmatize. And remember that for lemmatization with WordNet, we need to pass the part of speech tag. So here I'm passing part of speech tag, and then it can give me the lemma for this particular form, inflection. So lemma of studying is study, lemma of studied is study. So this is not very convenient to use, and later we will see a better method for lemmatization. Okay, now stemming has a similar purpose, but it's more aggressive. What it does, it's crude chopping of affixes. So if we have words like automates, automatic, automation, they all are reduced to automat. Okay, and usually these reduced forms, which are called stems, they are not actual words, actual English words themselves. So what happens is that after doing stemming, the text usually becomes unreadable. Now, a popular stemming algorithm for English is Porter stemmer. And again, so if you want to use stemming, just be careful because it can be really aggressive sometimes. So here I'm showing you how to use this Porter stemmer. So I create this again from NLTK. I'm importing this Porter stemmer, and then I'm creating an object of Porter stemmer. I'm tokenizing my text, and then I'm stemming each token. And here I'm showing you the text before stemming and after stemming, and we see that this located became look at. And again, this is not a proper English word. Then beautiful became beauty, and very became very. So it can be really aggressive. If you want to carry out stemming, make sure to examine whether this is what you want to do to your text or not. So far we have been using NLTK to pre-process text, but there are many other available tools. A common one, a popular one, is spacy. As we have seen before, it's a lightweight, fast, and convenient library. And depending upon what model you use, you can even access word vectors using this library. Also, it has multilingual support. So let's try out spacy to pre-process our text. As usual, if you don't have this model in your environment, you will have to download it. Okay, now let's try to pre-process our text. As usual, I am creating this doc equal to NLP of text. Now, spacy pre-processing gives a lot of information. Here I'm showing you 3 things. The first one is accessing tokens. So once we do this doc equal to NLP of text in this one line of code, it actually carries out many different things. And then we can access different information from this doc object. So let's first look at tokens. How do we access tokens? We can just write this loop for token in doc and we can get these tokens. And these are the tokens written by spacy. Okay, so it carries out sentence segmentation and word segmentation, and it identifies these tokens. Now, of course, it's going to make some mistakes. Again, it's a machine learning model. It's going to make mistakes. The second thing I'm showing here is accessing lemmas. How do we access lemmas? We can access lemmas using this .lemma property of each token. So for each token in our document, in our doc object, I'm accessing lemma of that token using .lemma underscore. So for example, lemma of is B, and so these are the lemmas of all tokens in our text. We can also access part of speech tags associated with each token. And how do we access these part of speech tags? We can just do token.pos underscore and it gives us part of speech tags. And here are the part of speech tags associated with our tokens. Usually, given text data, we are interested in extracting information from the text. We want to know who did what to whom. So there are some common tasks in NLP pipeline. And some example tasks are part of speech tagging, named entity recognition, co-reference resolution, and dependency parsing. Now we are not going into details about these tasks because otherwise each of these tasks would be a separate lecture on its own, and we don't really have time to do that. So here I'm just going to describe each of these tasks in one sentence. Part of speech tagging task, we already have seen this before. It is about assigning part of speech tags to all words in a given sentence. Named entity recognition is another common task. This task is about labeling named objects like people, organizations, or locations. Co-reference resolution is deciding whether 2 strings refer to the same entity or not. For example, given these 2 strings, UBC and University of British Columbia in text, although they have different surface forms, they refer to the same entity. Then another common task is dependency parsing. And this task is about representing grammatical structure of a sentence. That is, what is the object, what is the subject, and what's the action. Let's look at a couple of examples. Let's first look at how to extract named entities using spacy. Okay, so this is our example text. University of British Columbia is located in the beautiful province of British Columbia. And how do we access named entities from this text? We just use this doc.entities and we access each entity from doc.entities. And this is what we get. In this sentence, University of British Columbia is located in the beautiful province of British Columbia. spacy identified 2 entities. The first entity is this organization, University of British Columbia, and second entity is this geopolitical entity, British Columbia. And if you want to know what is the meaning of these labels. So this org label and GPE label, you can just do spacy.explain and that label, and it gives you explanation for that label. So for org, the explanation is companies, agencies, institutions, and so on. And for GPE, the explanation is countries, cities, and states. One more example. Let's carry out dependency parsing using spacy. So here is our sentence, I like cats, and we are doing NLP of this sentence, and this is what we get with dependency parsing. So in this sentence, these are our part of speech tags, and like is our verb, and I is the subject of this verb like, and cats is the object of this verb like. Now I just showed you a couple of examples, but there are many other things possible with spacy. It's a powerful tool, and you can even build your own rule-based searches. And as we have seen before, with spacy you can also access word vectors if you use bigger models. So that's all I want to say about basic text pre-processing.